we all thought that some clever biologists had proved evolution is true. To us, it made no sense. To even the atheists, it made no sense. But what do we know? We're just chemists. We're not biologists. So we just assume somebody else has demonstrated what to us appears to be sheer nonsense.
Yeah. Greetings to the brightest audience in the country. This is Real Science Radio. I'm Fred Williams.
And I'm Doug McBurney, Bible student and amateur comedian. It's good to be back with you, Fred, talking about real science on Friday.
So speaking of science, we have a speaker tonight at Rocky Mountain Creation Fellowship, and that's Joel Tay of Creation Ministries International. You don't want to miss this. I heard this guy speak at the CMI conference last summer. He's really good. It's going to be a great talk. So if you can make it out to Littleton Baptist tonight at 7 p.m., it's going to be great. And to find out more details, go to youngearth.org. That's youngearth.org. And you can, from there, you can get directions on going to that meeting. All right. Doug, today we're going to address the question of abiogenesis. So wait a minute, Doug. So is it abiogenesis or abiogenesis? I figured if we're going to talk about it, I probably should get the pronunciation right on this guy.
You know what, Fred? Amazingly, I think you got both of those wrong. I didn't know that was possible. Anyway.
Well, in radio, but Bob taught me years ago when we first started radio, when you read a bunch of stuff and you haven't really heard it said that much, then when you go on radio, it's like, you probably should figure out how that word's pronounced. So I thought I'd rely on my co-host to tell me how to pronounce abiogenesis.
If I'm not mistaken, and I could be mistaken, I think it's abiogenesis.
Abio, gotcha. Yeah, that makes sense.
With the accent on the A and the J, abiogenesis. I believe that's it. Yes, I remember Fred, Bob working with you to cure your tendency toward homonid versus hominid. Do you remember that?
Oh, I do remember that. Homonid. It took quite a few shows to break me that habit. Homonid this, homonid that.
Yeah. Well, I'm not sure any of us can help you with your pronunciation, Fred, but to help us answer the question of whether or not life could spontaneously arise from non-living matter, I want to welcome back to the Real Science Radio airwaves, Dr. Royal Truman. Welcome to the show, Doctor.
Thank you very much. I'm sort of relieved to hear that others have problems pronouncing words. They say English is a very simple language, but actually, it's one of the most difficult languages to figure out how to pronounce anything. And I've got the same problem. You don't read the way things are spelled. Look at the words 1, 2, O-N-E. That's pronounced one. Don't have to start off with number 2, T-W-O. That's pronounced wool. No. 2, I think, right? So I had that problem also.
So, Royal, is your native language, is it German?
German was my 4th or 5th language, actually.
Oh,
but
wow.
It's the language I use primarily now. Yeah.
Oh, wow. Okay, because you live in Germany.
I live in Germany now.
Oh, wow. Yeah. Gotcha.
Oh, my. Well, what is your native tongue?
I was born in Dallas, but moved to South America when I was 4. So my education and everyday language was mostly Spanish initially, and then it just went on to other languages as I moved around.
Wow. Okay. Oh, wow. Multilingual.
Now, are you still able to pull off a little Texan if you had to?
Well, I have to stop and think about that.
Drop in a y'all here and there.
Y'all, howdy.
Well, if you're from Dallas, you know what the plural of y'all is.
Ye?
Well, that's pretty close.
Now,
I believe it's all y'all.
Oh, all y'all.
That's good. I believe so.
So, anyways, Dr. Truman, he has a bachelor's degree in chemistry and in computer science from SUNY Buffalo, an MBA from the University of Michigan, and a PhD in organic chemistry from Michigan State, and then did postgraduate studies in bioinformatics at the universities of Heidelberg and Mannheim in Germany. And Dr. Truman was with us a couple of months ago on a show on why scientists believe in evolution. It was a great show. I think it's maybe right now on YouTube. It's our second most watched show. That was really fantastic. It stirred the pot with some evolutionists who left some, comments that were not, favorable for, they weren't real kind, but, it just shows you we're definitely hitting on the truth when you hear, from the other side like that. But anyways, thanks for that show, Dr. Truman. It was fantastic. And we're looking forward to you telling us about abiogenesis, which you'd be a foremost expert on because of your PhD in organic chemistry.
It's something I've been interested in for the last more than 40 years.
Well, an awful lot of people have been interested in it for an awful long time. And by the way, before we get started on abiogenesis, I want to point people back to the previous show. Why do so many scientists believe evolution? Because that show is an exercise in the analysis of not just science, but psychology. And it's just a brilliant analysis, I must say, Dr. Truman. In fact, I want to start today with a recent news article, since we're talking about how many people have been interested in abiogenesis for such a long time. I have a news article that I picked up last weekend. I'm going to call this an alleged news item. It's an article by a gentleman named Christopher McFadden, and it appears on a website called interestingengineering.com, which I was kind of surprised to see an article on abiogenesis on interestingengineering.com, because I go there fairly regularly. I'm directed there for actually very interesting engineering stories about real engineering, which is interesting for me. But here they invited this gentleman, Christopher, who graduated from Cardiff University in 2004. He has a master's in geology, and according to his bio, he has worked exclusively for his entire career within the built environment, occupational health and safety, and environmental consultancy industries. And he's qualified, listen to this, he is a qualified and accredited energy consultant, a Green Deal assessor, and a practicing member of the Institute of Environmental Management and Assessment. I'm not sure what a Green Deal assessor is. Have you heard of that one? Have you heard of that one, Royal?
I have a suspicion what it means, but let's not go that way.
Yeah, like Green Deal assessor. Okay.
So he has written an article. We'll link to it at interestingengineering.com. 7 of the most popular theories for the origin of life. And I just want to give you his opening line from the article. By the way, this is the type of article that appears in the news feed of people who go to Facebook and Instagram and who check their Yahoo and their Hotmail, these news feeds. And Christopher opens with, listen to this. He says, quote, "Apart from its sheer beauty, the one standout feature of our home planet is the existence of life. It's everywhere you look. But where did it all begin?" There's your opening line, right? As you're scrolling, you're about to check your Yahoo, you find out that one of the most brilliant minds, college graduate, is wondering where did it all begin. And then he goes on and he says this question of where did it all begin? It has plagued our species for millennia and will likely consume part of our thoughts for millennia more. And you know what that reminded me of is 2 Timothy chapter 3, verse 7, where it talks about people who are ever learning and never able to come to a knowledge of the truth. Have you ever heard that one?
Boy, that's a good verse. It kind of sounds like Yoda-esque to me, even though it's in the Bible. Ever learning and not coming to the knowledge of the truth, you will. Sorry for that. That's my bad Yoda impersonation.
No, that's good. There's a lot of not only Star Wars stuff, but a lot of science fiction stuff in general is lifted from the Bible. I'm glad you made that reference. Yeah. Now, Chris, the author, he goes on and he says, let's see, he says, apart from creation theories, many other theories for abiogenesis, the idea that life arose from non-life, have been proposed through the ages to varying degrees of credibility. However, none of these can fully explain the origin of life on Earth.
And it's interesting, Doug, his subtitle, he said, where did life all begin and how? Let's find out. And so now we're going to find out how it all began. And he lists the 7 most popular theories, and he starts with spontaneous generation was popular for a long time. That's the popular theory, spontaneous generation. Is that a theory or kind of a low-grade hypothesis?
It's barely an assertion, right?
So the number 2 is the primordial soup theory has been very influential. The primordial soup, that life began in like this soup on the earth billions of years ago.
And then the soup, of course, if you say, well, where did the soup come from? They say, well, refer back to number 1.
Spontaneous generation.
Well, of course.
Yeah.
And then number 3, life may have started next to hydrothermal vents. Hydrothermal vents down in the bottom of the ocean, the black smokers,
Yep. Yeah.
And but it started next to the hydrothermal vents, but how did it? Well, refer back to number 1.
Yep, exactly.
Just refer you back to number 1.
And then number 4, they say, could life have been molded by clay? Mm-hmm. So a slight biblical, connection
I was gonna
there.
Say, that's almost biblical.
Yeah. Of course, they won't go there. No. And then, he even quotes the Bible on that, at the end of that section for number 4. He says, perhaps there is something to this quote from the Bible after all. Oh, Lord, you are our Father. We are the clay and you are the potter. Isaiah 64, verse 8.
Wow. Well, that I've noticed this, that people who write about subjects like this, they often borrow just enough from God to lend them a little bit of his credibility.
Yeah, good point.
That's what that is right there.
Yep.
And then he goes on, he talks about ice, number 5. I'm not sure what happened with the ice. We'll refer back to number 1. And then it all started with RNA, of course. RNA, how did that happen to come to? Well, refer back to number 1. That would... Don't refer to Isaiah. Don't refer to Isaiah. Refer back to number 1. And then finally, Fred, of course, Christopher, let me get his name right here. Christopher, the Green Deal assessor, right? a graduate of Cardiff, Christopher McFadden, has a master's in geology. Finally, number 7, he says, I'm not saying it was aliens, but it was aliens.
He is the Green Deal assessor, green men. It came from green aliens.
There you go. Well, so Dr. Truman, you are our resident expert. I want to ask you about these top 7 and other theories. Please help us understand.
Okay. There are many other theories in addition. What's happening here, guys, is that people are looking at different aspects of the problem. That means for life to be possible, many, many, many things must fall into place. The problem is the environmental conditions are incompatible with most of them. So you focus on one particular topic, and then you say, oh, that particular little problem, a little part of the total, that could be satisfied best under hydrothermal vent conditions, very hot conditions. But, we got another problem. What about racemization of amines? Bad under hot conditions. Okay, and now you've got other theories like ice crystals, and under ice, you can protect from UV light. So basically, it's like saying you're trying to create an airplane and you've got to find the right conditions. Well, near a volcano's bad to explain where the fuel came from.
Right.
Maybe another environment would be good to explain where the plastic part came from. And so that's why you have this mishmash.
Oh, I got it now. That helps me understand Mr. Green New Deal's article much more effectively. Thank you very much for that. Wow.
I should maybe make one comment, and that is focusing on the question of where does life come from, or where did it started? It's misleading
Oh, okay.
because because you can speculate in any way you want by defining life any way you want under any conditions you want. But if it doesn't explain how life as we know exists arose, it's a waste of time. See,
Okay.
we know about life. We know how our bodies work. We know about biology. We know about organisms and plants and animals. We know all this. We know about the genetic code. That is what we have to explain. And that's why you've got all these theories about there could have been something lifelike that was a series of chemical reactions that interacted. Or it could have been something kind of like crystal-like and it had certain properties, or. So what? Because there's no path from that starting point to that which we are trying to explain, and that is life as we can describe it today.
So that explains the final line of his introduction when he says, there are all these theories with varying degrees of credibility. However, none of these can fully explain the origin of life, right?
And they barely get out of the starting gate. I mean, I think your point, Dr. Truman, is the huge gap. They're trying to start with like some just so story of how everything began. But when you actually consider life that we can already look at, how do they explain things, for example, like the DNA, the information that resides in the DNA? And, you know, you've talked on that. You've mentioned that concept before about how important it is to have like computer science knowledge to even be able to do biology.
Mm-hmm.
Yeah. And, you know, Sal Cordova touched on that too in a recent show. So they're skipping lots of stuff. I mean, it's real convenient to try to come up with stories on how everything began. You know, some vent in the ocean, some primordial soup. Okay.
If you let me share the screen, put some thoughts together that perhaps could help us, let's just say, frame the problem in a way that's more constructive, meaning what is it that we are trying to explain and how do the origin of life people go about looking at aspects of the total picture?
Mm-hmm.
Yes, absolutely. And speaking of the total picture, if you're listening online, if you're listening on the radio, if you're listening on the radio, don't click the link and open the slides if you're driving. But we will put a link to Dr. Truman's slides so that you can follow along. If you're watching on YouTube, you'll be able to see. Yes, Dr. Truman, help us understand.
Okay. I was thinking about some of the issues that you just mentioned, and I put together a few thoughts and I gave it a title. One of them is it occurred to me that origin of life chemistry is demonstrating, it implies that design is necessary. It's necessary for them to even conduct any kind of a meaningful experiment at all.
Yes.
And second title for the same concept would be, okay, knowing this, how do you interpret the results or the claims of origin of life chemistry experiments correctly? How do you explain it? How do you interpret it? And my thesis for the next couple of minutes is going to be that it is only possible to understand origin of life chemistry if you understand the design going into it by highly trained chemists. So there are thousands of publications and many theories. You mentioned 7. There are dozens of theories because basically anybody can come up with any halfway plausible idea and it gets published and actually just leaves them more confused more than anything else.
Mm-hmm.
You have many theories when you have no answers. Or there's a word in German, Eckpunkte. If you have no cornerstones, like in a puzzle, then everything's open. And that's the problem being faced with origin of life. There's like nothing that one can establish or set as, okay, here's some facts, and that funnels or channels our thinking. Like everything's open because there are no answers.
Yeah, a smorgasbord of theories. Like Walter Riemann said, it's like how fog adapts to the landscape. You just pick what you want off the buffet. We'll go with that.
That's right. And my observation of the years is now the explanations, experiments are becoming ever more exotic. What that means is the easy answers, the stuff that people thought would work, have been exhausted. Primordial soup, things like that. Frankly, I thought that had been exhausted years ago because any organic chemist knows that these molecules hydrolyze in water, and that's really a horrible place to dump a bunch of chemicals and expect a living cell to come out.
Yeah, because water is
Yes.
like it's very corrosive, right? I mean, it can't begin with water.
Right. Under
No.
normal conditions, if you do get any chemical reactions, then of course it's going to react with anything it can react with. And water is a great solvent, and it's a great way to degrade things.
Yeah, it's
Right,
a
and
great
so
solvent. Yep.
Yeah, that solvent should have, as you said, exhausted that theory. But in the kindergarten, first grade, second grade, third grade, in the elementary school curricula, no crackpot theory is ever exhausted. They continue decades and decades after they've been exhausted in the scientific world. They still appear in the textbooks of the kids in the schools.
I claim they will continue to exist until somebody says we can retire it because now we have another naturalist explanation. Until there's no godless explanation, then you go along with a bad explanation.
Yeah,
Right,
yeah.
right.
And speaking of water, we actually had a show on that. You can find it at rsr.org/water. So Bob actually emailed in a question to a NASA astrobiologist about her claims about how, they're looking for water on all these other planets, and like on Mars and this and that. But when he sent in his question, he was able to get her to admit that water would be destructive for the beginning of life. It was pretty remarkable. It was like, the elephant in the room that Bob is able to expose by his mail-in question.
That would be perhaps a good, more advanced topic. If somebody has inclination of time, we can go into that. How come water is necessary and how come water is present? 90% of cells is water. How come that works, but it does not work when preparing the simpler compounds that are necessary before you can get DNA, before you can get proteins? Those things are highly degraded. In the cell, you have other properties that allow water then to coexist with folded, protected proteins. That's a rather interesting topic.
Yeah, that's like you said,
and
it's part of an engineering design. You can't get around it.
Yeah.
It has to be designed ahead of time for it to work.
Right, and maybe that explains why, as you said, the origin of life explanations become more and more exotic.
Yeah. That's right. Become partially because the other ideas don't work, and partially because as more and more is understood about how cells and biochemicals really work, then one realizes you're going to have to come up with more complex theories.
Right.
But I've got to say that one thing I've observed is that none of these theories are conducted under what one would call plausible prebiotic conditions. For example, a factory in which microchips or airplanes are built is not a plausible prebiotic condition. These would be equipment set up, everything planned and scheduled and organized for a purpose to force an outcome. And prebiotic conditions must not have that.
Mm-hmm.
Wow, that's a difficult condition to come up with, isn't it?
Yeah, that's why no experiments actually do that. Nobody really says, what do we think conditions may have been like? What sort of gases were in the atmosphere? What kinds of temperatures? Let's just kind of put those conditions together and see what happens. Nobody does that because a chemist already knows what's going to happen. See, we know this much. No, we know about nature. We know how chemicals interact. We know about thermodynamics. We know about kinetics. There's no point wasting time on something that we know is going to go nowhere. So therefore, the key to understanding this kind of research or to conduct the research is you've got to have some kind of a goal. You're trying to explain something, not the whole cells, the whole organism, but just some sort of a chemical aspect. You've got to understand this. And then you kind of retro-engineer your thinking. How do I bring the correct chemicals together in the right manner to force them to lead to that particular outcome?
Mm-hmm.
It's got to be planned, it's got to be guided. And that is the key to conducting periodic chemistry. You've got to have something you want to explain, something simple. And then you spend years figuring out what solvents, what conditions, what temperatures, what purification methods, what to get that outcome. And then, so to get that published, and so people don't laugh at you, use a phrase like plausible conditions.
Yeah.
You don't say, here's how we think it happened, or here's a good explanation, because it's not true. But you're sort of saying, please don't laugh at me, but it's like kind of plausible.
Yep.
And that is a key word you'll find over and over again in publications, the word plausible.
Yeah.
Whenever you see the word plausible, you know right away it's periodically nonsense.
Yeah. Plausible deniability.
There you go.
So that whenever I read these, Dr. Truman, from now on, when I see the word plausible, I'm going to replace that with "please don't laugh at me."
I mean that seriously.
Mm-hmm.
That's
other
why
words
it's so
could have been
funny.
used. Other words could have been used. Realistic, conceivable, but the word plausible is part of the vocabulary of origin of life research. It's part of the vocabulary.
Ah,
You have to throw it in, because if anybody can say that's not even plausible, at that point you expose yourself to ridicule.
right.
Yep.
There's got to be some semblance of plausibility.
It just has to have just the ring of even the slightest hint of plausibility, and they can kind of feel like they got away with
now
it.
Dr. Truman, you're delving again into the psychology of this.
Yeah.
I hadn't really thought about that,
Yeah.
but the word plausibility is a little bit soft and mushy and flexible, and it kind of protects you from, you're not setting up any sharp edges that anyone can attack. It's a little soft and mushy.
Interesting point. My experience in chemistry, especially in graduate school, is that it's a rather brutal and demanding art. That means more than any other area I know, people really demand clear thinking and no nonsense.
Mm-hmm.
You're always challenged. How do you know that mechanism is true? Have you excluded this possibility? These rules don't apply typically to chemical origin of life research. And that's what's so disconcerting, because a chemist is trained to be very precise, because the work has to be reproducible. The mechanism has got to be very, very carefully validated through many, many independent pieces of evidence. But when it comes to abiogenesis, the rules are different. A huge amount of pretty crazy speculation is allowed.
Yeah. So, Dr. Truman, I'm just curious, when you did your grad work, I'm guessing that there wasn't a lot of talk of abiogenesis among your colleagues. It was maybe more reserved for the drink after work.
Not even that. I don't remember it mentioned once.
Really interesting. Okay.
No. You see, we all thought that some clever biologists had proved evolution is true. To us, it made no sense. To even the atheists, it made no sense. But what do we know? We're just chemists. We're not biologists. So we just assume somebody else has demonstrated what to us appears to be sheer nonsense.
Yeah.
No, that's what it was.
Yeah, and that's not uncommon. I mean, you have biologists. Like, I remember when I had an email exchange with Dr. James Crow. He used to write prolifically for Nature magazine.
Yeah.
And he admitted that he didn't have really good evidence for evolution in the field of biology, but he said, well, yeah, but they've got all kinds of evidence in paleontology and astronomy and these other things. So he couldn't
Correct.
appeal to his own discipline. So even in the case of biology, this guy was a geneticist, and he could not understand how evolution could occur in his own
That's
field.
correct. That is correct. And that is one reason why I sometimes go back to chemistry and talk about these issues, because at least chemistry is, in theory, a very precise science. That means that you should be able to talk about real things in a real manner. Paleontology and other areas are extremely flexible in terms of model building. You can rebuild fragments of skeletons or fossils in many ways, and it's in a sense very very vague. But
Yeah.
chemistry, if you've done real chemistry, you should be publishing how the experiments are conducted. Then somebody else can go and say, okay, I understand why you do it that way. You're trying to force a particular outcome. I understand the reasoning behind it.
Yeah. Very specific, very tangible.
Yes, it's a more sciencey science. It's a less artsy science.
That is correct. In most other areas, evolution is kind of an intuition. Lots of time, things get better and better. They sort of natural selection just sort of creates miraculous things, and this kind of intuition allows a lot of imagery. But this imagery, and people are very good at thinking in abstract imagery. It can be very useful. Can lead to a lot of mistakes. And there's where you got to get out your pencil and start working with the fine details and start working with real science to then see, does this imagery have any basis to it?
Yep.
Yes, and that brings us right back to the chemistry. Let's get back to the chemistry.
Right. Okay. Then you mentioned the 7 theories, though there are many other theories. It's good to kind of step back for a second and ask ourselves, what is it that we're trying to explain? And we really want to explain that which we observe today. Very complex living systems, okay? And a starting point are cells, because the cell is the foundation of how organisms are built. So cells are absolutely indispensable. You find them from bacteria to multicellular life. You've got to have cells, or you haven't got anything that resembles biological life. Anything that's not a cell is a redefinition of life, which has no meaning or purpose. Because if you can't get from that to a cell, you've explained nothing anyway. So you're inventing something and then trying to explain something that doesn't need explaining because it never existed and there's no evidence for it. So we always got to go back to the minimum, which is cells, real life.
Yeah. And it's interesting. The minimum, Darwin thought that the cell or whatever was like this simple black box. So going back to the cell is more complex than like the entire city of Tokyo was one analogy of just all the interactions that go on. But anyways, Dr. Truman.
So let's think about just cells, not in a lot of detail because we're talking chemistry today, not molecular biology. First of all, they're highly adaptable to changing conditions. Cells interact with other cells. They can form tissues, they form organs. Bacteria have sensors. Highly adaptable, okay? They can use different kinds of nutrients. Now, they have to be able to manufacture thousands of different parts in order to reproduce and to create an offspring. The offspring itself needs all of the components. You don't just create a little bit of a membrane and then the new cell's alive. You've got to create extra DNA, extra RNA, extra proteins, and all of this has got to be in a functional, interactive, living state before you can bud off the offspring. It's these thousands of different parts that attract chemistry to origin of life research, because that's something they can sort of understand. They can't understand the cell, but they can understand some of the components. For example, a cell has got to manufacture its own amino acids. So therefore, abiogenesis, people say, fine. So from nature, we need to find a way to create amino acids. They've got to then link together to form proteins. These proteins have to have the right sequences so they can perform catalytic and structural functions. We've also got to produce sugars like ribose and deoxyriboses. We also need nucleobases to which the sugars can be attached. And then these nucleobases, phosphates, all these things are linked together to form nucleotides. And these nucleotides are attached along chains to form DNA, RNA. We need carbohydrates, we need lipids, we need cell membranes. All of this kind of has a chemical flair to it. We can understand what an amino acid is. We can sort of come up with ways that amino acids could have been created from other molecules, whatever. So when we talk about abiogenesis, what we're talking about is only the minimum infrastructure that goes into building a cell. We're not talking about the information that is present in DNA. We're not talking about the complex, regulated metabolic processes going on. All of that is now molecular biology. It's very complicated. But before that can happen, you've got to have the infrastructure, the bare bones chemistry.
Yeah.
And that is the end where people kind of scratch their heads and say, you can't even get that right. Where in the world are the large proteins supposed to have come from? And this is now what has been going on for decades in the origin of life community, trying to find ways to put together those kinds of chemicals. That's all they're doing.
Yeah. And while you were explaining that, I'm thinking, from my background as an engineer, you're saying things like it needs the right sequence. I mean, all of this points to an engineering infrastructure. If you were describing this to me, and I don't have any, bias, some a priori bias to one thing or another, I'm thinking of an engineering system. I'm not even thinking of this all happening by chance. And we haven't even got into the nitty gritty, like you said, into the molecular biology, the information, all that stuff. It's just to get the infrastructure. They're already appealing to intelligent design from my perspective.
That's right. That's why I made the point before that focusing on a hypothetical, totally unknowable, original source of life is extremely vague, because what people are doing is they're speculating about infrastructure components that allegedly may have been lifelike in some sense, the infrastructure, but the really interesting stuff is not being addressed. And those are the engineering aspects, the regulated aspects, the reproductive aspects, everything that goes into real life.
Yes.
So when we talk about chemistry, we're only talking about the bare bones first conceptual step.
And Dr. Truman, is it am I understanding you that the origin of life branch of science, if it can be called that, is it really just focused on trying to make chemicals, or how chemicals came about?
Yeah, you're right. Some people distinguish between evolution, which is like after, let's say, complex systems like cells were there, and pre-evolution, which is considered abiogenesis. You can't make a distinction. Either there's a natural continuum from simple molecules floating around in the atmosphere to us flying around in airplanes. Either a natural continuum or there's not.
Yeah. And that's maybe part of the reason, maybe the appeal to panspermia or aliens seeded life here. Right. So, well, Dr. Truman, this is really interesting stuff. And unfortunately, we've had so much fun diving into this. We're actually out of time.
No.
Dr. Truman, we would love to have you back for a part 2 if you're willing, because
Sure.
I'm sure there's so much more to get into. I mean, I'm looking at some of what your
I want to get
slides,
past just the chemicals. Can we get past just the chemicals?
Back to the roots.
Yeah.
Of course.
Okay. Okay, well, great. So, Dr. Truman, we will have you back next week. So, just a reminder to our audience that Joel Tay of CMI, Creation Ministries International, will be at Rocky Mountain Creation Fellowship meeting tonight. That's at Littleton Baptist Church. And also, if you can help us out, go to rsr.org/store. And, we've got lots of great materials all across the store. You've got stuff on, the Big Bang. We've got Unlocking the Mysteries of Life that'll get into more of the topics that we're talking about here. So many good materials, and it really helps us out. You can also sponsor a show, and there'll be a sponsor link on the top of the page. And also, by the way, if you have questions for Real Science Radio, we might do a show in the future that just answers specific questions that you may have on any topic related to science. Maybe you were wondering, where did Cain get his wife? Questions like that. So please feel free to email those in, and at some point we'll do a show answering specific questions. So Dr. Truman, I want to thank you again for joining us, and I'm looking forward to next week. So for Doug McBurney and Dr. Royal Truman, I'm Fred Williams of Real Science Radio. May God bless you.